Hello everyone and welcome back to the JMZ Online YouTube channel. If you clicked on this video, you probably already know that today we're working on a 4.2 liter inline-6 Jaguar block out of a 1968 E-Type Series 1.5. This engine has dry sleeves installed from the factory, which we originally planned on boring 20 thousandths oversize until we found some issues during our inspection. When doing our magnetic particle inspection, commonly referred to as MagnaFlux, we discovered multiple cracks on the deck surface of the engine block between the cylinders. Aside from the cracks that were clearly visible on the deck surface of the block, the MagnaFlux was also picking up on cracks running down the backside of the cylinder sleeves. Finding cracks in an engine block is one of the worst case scenarios you can encounter on a numbers matching restoration. Initially, I believed that this block likely had Siamese bores, meaning no coolant ran between the cylinders. However, after doing a bit of research, I learned that there are actually two small coolant passages between the cylinders at about 1 and 2 inches into the bore. Now, after consulting various different sources, I was told everything from junk the block right now to re-sleeve and send it. After discussing with our customer, we decided that our best course of action would be to remove the old cylinder sleeves so that we could get the full picture of what's going on behind these bores. As such, I went ahead and got the block set up on our boring machine and clamped down tight. I needed to do a tool change from the surfacing head to one of our cylinder boring heads before we got started here, which is as simple as removing the 4 nuts to drop the surfacing head onto the tool change caddy, rotating the caddy around to the boring head, and lowering the column of the machine to the boring head and reinstalling the 4 nuts. If you've watched our channel for a while, you know that it's impossible to do this operation without dropping at least one of the nuts and washers. If you haven't watched our channel for a while, I'd say it's time to subscribe and go through some of our old videos. If you operate a machine shop, you likely have a feel for how much you can trust your machines based on how well you maintain them. Often when setting up a block for machine work, we'll simply use our precision level to double check that the block is set true to the machine. But since the internet always questions that, I figured I would quickly run a dial indicator across the deck and show you why we trust ours. On an engine that's over 50 years old, you're likely going to see a few thousandths variation in the deck surface, but most importantly, we found that all 4 corners of the deck were well within a thousandth of each other, giving us confidence that our setup was true. In addition, I could also use our boring machine's built-in dial indicator to run from the top of the cylinder to the bottom and verify that the cylinders are perpendicular to the deck. They did show to be true, with the exception of the very top of the cylinder where the wear is from the pistons. To remove the old cylinders, we're going to be boring them out until they're paper thin, making them easy to remove with a pick or a chisel. Rather than blindly following the printed specifications, I was able to use telescoping gauges to measure the diameter of the parent bores from the bottom side of the block. I learned to use the telescoping gauges back in college after watching a video from A-Bomb79, but I will say I struggle greatly due to my essential tremor, so I prefer to use a bore gauge whenever possible. The edge of the sleeve was also exposed on the top side, so I could get a rough diameter measurement with the calipers, and both of these measurements came in within a few thousandths of the printed specification of 3.761 inches, giving me the confidence needed to set up our cutters. While our machine could easily handle removing the sleeves in a single cut of 120 thousandths of an inch, we decided it would be safer to go in 2 cuts, with the first being a 100 thousandths cut, increasing the bore from 3.625 to 3.725 inches. Next step in the process involves using the machine's built-in indicator, again with the centering finger running at a low RPM in the center of the first cylinder, allowing us to adjust the position of the X and Y axis until the indicator runs true. With the cylinder centered up, we can install our first cutter into the boring head and prepare for our first cut. As a quick double check, I ran the cutter down close to the top of the cylinder to give a visual check that we weren't off-center or set the cutter too big. Next, we turn on the spindle and set it to around 400 RPM, which is usually a good speed on this machine for this size of a cut. After letting the machine bore the first 1/4 of an inch or so, we stop the machine and raise the spindle so that we can make, again, one more visual check, and after determining that everything looked okay, we can continue on with boring through the entire cylinder. Obviously, a mistake at any stage of the process isn't great, but it would be much easier to repair if we caught it in the first 1/4 of an inch than if we bored the entire cylinder too big and then realized. As we wait for the machine to run, we go ahead and set our second cutter to 3.745 inches, which will be roughly a 20 thousandths cut, which should leave the wall thickness of the sleeve at around 8 thousandths of an inch. As you can tell, this is a much lighter cut than the first cut, and even though the machine could handle it all in one cut and save us some time, we want to be as careful as we can on a job like this. As we got our first look at the thinned out sleeve here, I noticed something that I personally had never seen before in my few years of doing this process. Towards the bottom of the bore, the sleeve had basically cracked vertically in many spots. I could see that we hadn't cut into the parent bore of the block, which was good, but this still had me a bit confused. As usual, I was able to get a pick behind the sleeve and break it out of the bore, and after pulling the remnants of the sleeve from the block, I realized what I was looking at. When this sleeve was installed, it galled the back of the sleeve and the parent bore significantly, likely due to either the press fit being too tight or no lubricant being used to install the sleeve. Now, it's hard to believe this would happen from the factory, but I have no way of telling whether or not these sleeves are original or if this engine has been repaired before. Finally, getting our first look at the water passages behind the sleeve. Even without any MagnaFlux powder, the crack is visible from the deck to the first passage and from the first passage to the second passage. On the opposite side, we can see that there is a crack extending towards the deck from the first water passage, which was not visible on the deck surface. The one thing we know, though, is that cracks only grow. With the removal of the first sleeve, our initial suspicions were true. Even in the locations where a crack was not visible on the deck surface of the block, it was likely that we would find cracks extending from the water passages toward the deck. It seems to be a weak point in these 4.2-liter Jag engines, as I found many examples on the internet, and other people who I reached out to said they had seen it before. Again, after consulting with the customer, we decided to keep moving forward with removing the rest of the cylinder sleeves so that we could get the full picture of what we have to work with here. This is a fairly time-consuming process and a bit nerve-wracking to say the least, despite the fact that as the block currently sits, it is already scrapped without additional repairs. I am glad that we decided to bore the old sleeves out as opposed to attempting to press them out, though, because I can only imagine how difficult and risky it would have been to press them out, considering that we found significant galling behind nearly every sleeve. For those of you watching who are maybe interested in the machining aspect but have less understanding of the automotive side, you may be wondering at this point why we don't simply just find a different block. But the answer really isn't that simple. First and foremost, it isn't as simple as running down to Walmart and picking up a new engine block, because there simply aren't new blocks available. You also have to take into account the rarity of an engine such as this, considering you don't see them driving down the street every day, and you likely won't find one at your local U-Pull-It lot. And that doesn't even begin to mention the fact that the vehicle in question is a numbers matching restoration, and a block with the wrong numbers can decimate the restored value of the vehicle to a collector. After finding nearly all of the sleeves galled, I set up a bore gauge to measure the parent bores of the block and found that the bores were around 4 thousandths tighter at the bottom than at the top, which could have easily contributed to the issue with the installation. That being said, I can't imagine how tough these sleeves were to press in and how they didn't manage to simply break them all going in, considering the amount of press that they had at the bottom. If we had simply been planning on replacing the sleeves in a block without any cracks, but we found the bores as damaged as they are here, we would be forced to go to an oversized OD sleeve so that we could bore the parent bore of the block and clean it up before installing the new sleeves. Aside from making installation even more difficult with the raised edges from the galling on the previous install, damage like this can also affect the heat transfer between the sleeve and the parent bore of the block. Nonetheless, we have to work with what we have if we want to save this numbers matching engine. Given the inherent design flaw, even if we were able to find a replacement block, there's no guarantee that it wouldn't be in just as rough of condition. With the block off of the machine and cleaned, the magnetic particle inspection showed cracks between every single cylinder, with most of them extending to the second water passage, but not beyond. No decision has been made yet, and the opinions of people I've consulted about the viability of repairing this block have varied wildly. I generally take the opinions in the comments with a grain of salt, but if you have experience with a 4.2-liter Jag like this, drop a comment and let us know your thoughts. So I made some different models to help with the visual, but if we simply install the replacement straight sleeves, we have something like this with the two sleeves here shown and the crack running up in between, which leaves the head gasket having to seal the water from the crack just on this thin area at the top of the sleeve. So picture water coming up over this crack. It has to seal right there on the sleeve before it gets into the cylinder. And the chances of this lasting very long are probably pretty slim. Now, what appears to be a common repair for these Jaguars and what we believe our best option moving forward is to install top hat or flanged sleeves which overlap at the top of the cylinder. So basically, right here you have your normal sleeve dimension with the outer diameter that would be the same as a straight sleeve, but at the top you cut a counter bore in the block, which is actually a larger diameter here for the flange at the top. And as you can see, they actually overlap here in the middle. And what that's going to do is give a lot wider area here for the head gasket to seal on. Now, looking at it here, imagine this this kind of bronze-looking area or gold-looking area is still the crack running up. But as it runs up over here, it's not going to be able to jump over the thickness of the sleeve right into the cylinder. It's going to have to move over, come up, which obviously it's still going to do. It's still going to come up probably right to here, assuming that it gets past any of a Loctite sealer, because we would probably install it with green Loctite retaining compound. And basically what that's going to do, the water will still come up here if it leaks through the retaining compound, but you're going to have a much wider area here for the head gasket to seal on, as opposed to this where you have this small area compared to this wider area. And here's kind of a picture of what that looks like. I found this from classicjaguar.com. Looks like they do a lot of really high-end restorations of Jaguars and other things, other vehicles of the similar vintage, and just some classy restorations there. So here you can see where basically they've installed these two sleeves and they've cut the counter bore for this center sleeve, which actually on this side overlaps into the flange of the next cylinder over. On this one, the bore spacing must be just slightly different to where it doesn't quite overlap, but you can see how much wider of an area that gives for the head gasket to seal. And with that, we still don't know if this is the end or not for this 68 Jaguar block, so be sure to like and subscribe so that you can find out in the future.